Okay, now in this example here, now we're going to look at sums, right? So now let's assume that we have these vectors. So we can do, as we explore the sum of two maps, so that, suppose that we have two linear maps that go to the same domain and codomain, so f and g, and the representation matrix for f is going to be given by this, and then this representation matrix is for g. Okay. Also recall that when we have a function, right, we have these two mappings for f and g, and this is the definition of a sum, that we add the vectors. So this is just a vector sum. Okay, so if we have this, the addition of this function, we have going from v to the sum of u and w. And so now what we're going to do is we're going to let these be the representations of the domain and codomain, or excuse me, for the input-output vectors, I should say. So here's the representation of the input vector, right, with respect to b, and here are the two representations of the output vectors. Okay, now, also, where d is given the basis, right, so this is the basis for the codomain, so we've got delta 1 and delta 2 vectors. We have this, right, so we have this vector sum, u plus w is given by this plus this, right, so all we're doing is just rewriting vectors u and w as a linear combination of the delta 1 and delta 2 vectors. And then we're regrouping things so that we have the u1 plus w1 with the delta 1, and likewise u2 plus w2 with the delta 2. And so this then gives us the representation of the vector sum given here. So the representation with respect to the codomain d of u plus w is given by this. Okay, so that's where we're at. Now, we're also, since these represent the actions of the maps f and g on the input v, okay, let's do that. So, where do I want to go? Let's go here. Okay, so now, what do? Let's do what the mapping does, right? So if we take the two mappings, so 1, 3, 2, 0, right? That's going to give us what? That's going to give us oops. Right, that for the first one. And then the other representation, -2, -1, 2, 4. -2. So -2, -1, 2, and 4 times v1, oops, v2 equals this again. This is going to give us our representation of -2v1 minus v2 And then this is going to give us 2v1 plus 4v2. Okay, now, adding the entries represents the action of the map f plus g. So let's write that. So here, now what we're going to do is we're going to add these. Right, so what do we get? We get negative v1 plus 2v2, and we get 4v1 plus 4v2. So therefore we compute the matrix representing the function sum by adding the entries of the matrices representing the functions. And so this becomes the matrix. And that's it. All right, cool. Have a great day.